Let's make a video. All right, so somebody asked about domain of a composite function, so I came up with this example. We have f of x equal to the natural log of x, which is a function whose domain is x greater than 0. So for composite functions, usually I kind of just think about these on their own. So this one, the domain is x greater than 0, or you could write it in the interval notation 0. I'm not going to be super specific, right? You can do that if you want to. And for g of x equal to the square root of x minus 5, the domain is x greater than or equal to 5, or if you prefer, 5 to infinity. So now I want to find the domain of the composite function. So what's the domain of f of g of x? So something to always be aware of, no matter how much the function simplifies, the domain of the inner function must always be observed. So I know without a doubt I'm going to have to be in some subset of this interval here. So I know for sure x is going to have to be greater than or equal to 5, and then there might be some additional restrictions. So f of g of x is f of the square root of x minus 5, which is the natural log of the square root of x minus 5. So in this case, I see that for this inner part here, well, I know that 1, x minus 5 has to be greater than or equal to 0. So x has to be greater than or equal to 5, which we already knew, right? We have to observe the domain of the function. But now we have to look at the composite function and say, okay, we know that the insides of a logarithmic function have to be greater than 0. So we also need the square root of x minus 5 to be strictly greater than 0, which is going to end up meaning that x has to be strictly greater than 5. Combining these together is going to give us that our domain is x greater than 5, or if you prefer, 5 to infinity. Right? X can't be 5 because then we'd be taking the natural log of 0, which isn't allowed. Alright, let's go the other direction. Meaning, let's do g of f of x. So g of f of x is, let me look over here, g was the square root, so it's g of the natural log of x, so it's the square root of not x minus 5, but the natural log of x minus 5. Alright, so again, we have to observe the domain of the inner function always. So the inner function, natural log of x, we know that x has to be greater than 0. But then we also have to observe the domain of kind of the whole composition of functions. So we know that for the square root of the natural log of x minus 5, we need the natural log of x minus 5 to be greater than or equal to 0. Alright, so I'm going to solve this by bringing the 5 over to this side, and then exponentiating both sides. So you can say e to the this, e to the that. So what we really got here is that e to the natural log of x, which is x, is greater than or equal to e to the 5th. Okay, so we need both of these to be true. If you're looking at a number line, here's 0, here's e to the 5th. This is actually a pretty big number. It's probably like, I don't know. Let's see, 3 to the 5th is 243, so 200-ish. So since both of these things have to be true, we have to be bigger than or equal to this. So we need all of this over here. So our domain in this case would be e to the 5th inclusive to infinity. Alright, I'm going to stop that there. That will be the first one. I'll do another one in a minute.